A very good evening, everyone. I am Asmita, Center Head JMA, and I welcome you all on behalf of Jamshedpur Management Association. Can anyone please confirm if I'm audible?
Yes, ma'am.
Thank you. So, once again, a very warm welcome. So, BAKE Business Acumen and Knowledge by Expert Talk series was initiated to bring different industrial experts on the JMA platform. Today, to discuss on energy management in industries, we have our guest speaker, Mr. T. Senthil Kumar, with us. He is a senior fellow, Industrial Energy Division at TERI. I would like to give a brief introduction of Senthil sir. He is a graduate in Electrical and Electronics Engineering from College of Engineering, Anna University, Chennai, from batch of 1991, and holds a master's degree in Business Administration, specializing in Production Management from Bharati Southern University, Trichy. He has got an overall experience of 30 years in industry and consultancy in the field of energy efficiency, renewable energy, power systems. He currently holds a position of Senior Fellow with Industrial Energy Division in TERI. Senthil sir is an accredited energy auditor from Bureau of Energy Efficiency, Ministry of Power, Government of India, and has carried out more than 400 energy audits in different types of establishments. The range of audit covers energy efficiency audits for industrial sectors, power quality audits, municipal water systems, street lighting audits for public utilities, power plants, etc. He's got an experience in working with multilateral developmental agencies as an energy expert in several countries in the field of energy efficiency and management. He holds a professional membership with Society of Energy Engineers and Managers SEEM, Thiruvananthapuram, Kerala, and Indian Society of Lighting Engineers, Karnataka chapter. He has published several technical papers in journal and in seminars has also co-authored a book, Light Right for Practicing Engineers. With this, I would like to welcome Senthil sir. Sincere apologies for the background noise. The presentation will be for 1 hour, which will be followed by question and answer session. Thank you, and over to you, sir.
Good evening, everyone.
Yeah, good evening, sir.
Yeah, so I will make my presentation on this particular topic, energy management in industries. When I was asked to make a presentation on the area of sustainability and the broad theme of sustainability, I choose this area of energy management in industries as this is my area of expertise. So I have prepared slides. I will just share the slides. Are you able to view the screen?
Yes, sir. Can you put on the slideshow, please?
Yeah. I have put it on the slideshow. So I have chosen this topic because this is the area where I have worked in my entire career. So I thought I will make a presentation because it is comes under the broad theme of sustainability. So today's presentation, it is for 1.5 hours, I was told. So I can make a presentation for about an hour's time, and we can have a question and answer session for the last half an hour time. I think that's okay with everyone. So in this today's presentation, I have tried to speak about the global scenario on basically on the climate change and how energy affects climate change, and how do we manage energy in an industry. There are various tools of managing energy like energy auditing, and the latest tools like IoT based energy auditing, and how energy management is executed by a proper financial plans, that is financing of energy management activity. And I will touch upon renewable energy and open access in power trading. And I also have some case studies which are basically based on the studies that what we have carried out from our institute in different industries, both in India and as well as in outside the country. So coming to the global scenario, it is predicted by World Bank group that the global energy demand will increase by 45% by 2030. That is, which requires around $26 trillion of investment. And out of this growth, 87% of the growth will be expected in the developing countries. developing countries meaning countries which are in transition, which are trying to achieve double-digit economic growth, mainly India, China, Brazil, and other countries which are in economic transition. There is a increased volatility in oil and gas supply, which everybody knows, and the greenhouse gas that are emitted from mainly from the burning of fossil fuels is expected to rise up to 45% by 2030 from the current scenario of 2020. In 10 years time, it is expected to grow by 45% and it will reach 45 gigaton. I will show you a graph. This okay. If I put it in on the slideshow, I'm not able to view the screen. I will explain it with this in this mode itself, and then go to the slideshow in the subsequent slides.
Excuse me, sir.
Yeah.
Can you put your presentation in slide mode, slideshow?
If I put it in a slide mode, I'm not able to view the graphs. This particular slide I will show in this mode, in this normal mode, and then later on I will switch on to the slideshow.
Okay, thank you, sir.
So if you look at the this particular graph, by 2020, the gigaton of emission is around 34 gigatons of CO2 emission has happened, and this is projected to go up to 40 gigaton by the year 2030. And if you look at the potential for reducing this energy in 2020, it is around 3.8 gigaton, and the same thing will be around 14 gigaton in 2030. If we are not going to achieve this one, the emission level will increase, contributing a higher CO2 levels in the atmosphere, resulting in increased temperature. We all know the effect of climate change. We all know the effect of climate change, which results in an increased temperature. The increased temperature results in higher extreme temperature, extreme rainfall, and sea level rise because of melting of glaciers and other thing. And one of the main reason of climate change is the emission of CO2 by burning fossil fuels, and these fossil fuels are burned mainly in industries and in transport sector. And of course, there is a little amount of climate change that too happen because of deforestation and land use pattern change in agricultural sector. But the bulk of the thing comes from burning of fossil fuels in the industries where we all work. So to achieve or to limit, I will not say to achieve, to limit the emission to say around 40 gigaton of this one, a good amount of opportunity is there to reduce the emissions by different ways, like induced efficiency, use of renewable energy, use of biofuels, switching over to nuclear fuel or carbon capture and storing technology. Yeah. So if you see that this curve, this is what I was trying to tell in this in the slide. 3.8 gigaton of this one is available in 2020, and the same thing is around 14 gigaton is possible by 2030. And these are the ways and means of which we can abate this one is through efficiency in power plants, use of renewable energy, biofuels, nuclear, and carbon storage. If this have to be done so that the red color line, the curve, can be bent or flattened so that the emissions remain at around 40 gigatons by the year 2030. See, as you all know, like the climate change results in rise in temperature. See, by 2020, as per the IPCC, this one protocol, we have to limit the temperature rise by 1.5 degrees Celsius by end of 2100. If you see at 2020, we are close to 1.1 degrees Celsius, and the current rate of growth, we will hit that temperature rise of 1.5 degree by 2040 itself. So we have to manage the use of energy so that the emissions are reduced, so that the climate, so that the temperature rise in the atmosphere is limited to 1.5 degree by 2100. So, but at the current growth rate, no, we may hit that 1.5 this one by 2040 itself, which is in a very dangerous scenario. So this results in an increased CO2 concentration in the atmosphere, resulting in an increased temperature rise and the subsequent no disadvantages that rises out of temperature rise. So this is what I was trying to tell, that temperature rise of 1.5 degrees have to be is trying what we're trying to achieve by 2100, and by 2040 the emissions have to be curtailed to 40 gigaton from the projected or from the extrapolated value of 55 gigaton. So how do we achieve this? Obviously by doing energy efficiency studies in industries, and to reduce the energy consumption in different processes that are happening in the industry. Mainly the energy efficiency is possible through different processes that are happening in the equipment, like mainly the furnaces, process coupling, increased material recycling, or switching over to non-fossil fuel electricity supply, that is mainly from electricity that are sourced through power plants which burn fossil fuel to solar or other renewable energy, or carbon sequestration storage methods which are used in cement industry. Material efficiency is another process through which we can improve the efficiency of the process, thereby reducing the emissions that happen, CO2 emissions. Product service efficiency, maybe like higher building occupancy, or through the vehicular efficiency, emissions can be reduced by better better mode of transport, like electric vehicles, or even in the petrol or diesel vehicles, it can be done by through carpooling or car sharing, so that the per person emission that are emitted through in mobility can also be reduced. So do energy efficiency potential exist? So this is one small study which was done in the cement sector. If you look at the cement sector, offers a huge potential for waste heat recovery. Mainly steel and cement are the two major sectors which offers a huge potential for improving energy efficiency by recovering the waste heat that are emitted in the process. So see, if you look at the waste heat recovery potential in the cement sector, the around close to 900 megawatt of waste heat energy can be recovered in the cement sector in India. But if you look at the extent to what we have achieved is only 200 megawatts. So still 700 megawatt of waste heat recovery potential is available in the cement sector alone in India. So like this, in each country, there's a huge potential in waste heat recovery, and of course, it involves it requires calls for a huge investment, and even in India, for achieving this close to 900 megawatt of waste heat recovery potential, we need to spend around $1,400 million. But what I'm trying to say is, we have hardly achieved only 1/5 of the waste heat recovery potential in the cement sector. So this is a study which is carried out to find out what is the extent of energy efficiency potential that exists in industry, and this is particularly on one industry and on one case study which has shown that the extent of potential that is possible. So if you look into it, which I'm not going into in depth on each and every industry, there is a huge amount of potential that to exist to achieve energy efficiency and thereby to reduce the emissions. So coming to Indian context, the Government of India under Ministry of Power operates through an agency called Bureau of Energy Efficiency. That is a nodal agency in India which monitors and coordinates all the energy efficiency activity. Under the National Action Plan on Climate Change, there are several missions. The first three missions are mainly related to energy and improvement of energy efficiency, namely the National Solar Mission, National Mission for Enhanced Energy Efficiency, and National Mission on Sustainable Habitat. Basically, these three missions tries to reduce the energy consumption by improving the efficiency of the end-use efficiency of the different equipment that are used in the process of generating efficiency or in the usage of efficiency. So in the international level, the Paris Agreement COP21, which was with the last one, which was held in the year 2015. Each country had come out with certain commitments by how much they will be able to reduce the emission. India, on its part, has committed that to that conference of parties, which is held under the aegis of United Nations, that India will cut down its emission by 35 to up to 35% from 2005 level by 2030. That means what was the emissions level in India in 2005? India has committed that it will reduce by 35% in the year 2030. So this India has committed based on the strategy that that we will shift from fossil fuel based electricity generation, not completely, at least 12% of the electricity that is generated through fossil fuel by 2014-15, and by 40% by 2030. So this is our strategy in one of the way of how to cut down the emissions, and also by increasing the forest covers by 2.5 to 3 billion tons of CO2 which it can absorb by 2030. India has committed to that UN body that we will be able to cut the emissions by 35% by the year 2030. Each country, based on its industrial growth development, they have committed different levels to the UN body. If you look at China has committed by 2060 it will become a net zero economy. That means it will completely eliminate the entire emissions from fossil fuels by 2060. By way of different strategies they have planned for, by going for renewable electric vehicles and so many things. Similarly, many European countries by 2050 itself they have committed that they will be reach the net zero emission in their entire production process in industries, transport sector, and even in agricultural sector by 2050. Of course, we have not committed, India has not committed when it will reach the net zero emission level, but we have committed by 2030 we will be able to reduce our emission level to 35% from the 2005 level. So if you look at the national solar mission, by 2022, India has targeted 100 gigawatt of solar grid connected solar power generation, and another 75 gigawatt of renewable energy generation through wind energy. So totaling around 175 gigawatt of power generation through renewable energy through wind and solar. Of course, we are very close to achieving these numbers. By next year, we will be definitely achieving it. And based on the progress what we have, the Indian power sector has achieved, the Indian government has also now set a higher target of having 450 gigawatt of renewable energy power by 2030. And I think by the way Indian industries have responded to the government target that Indian power plant should gradually shift from coal to renewable energy, the new target figures of 450 gigawatt by 2030 also I think India will achieve without any major issues. This is the earlier slide which I was showing is on the solar part. Coming to the energy efficiency part under National Mission on Enhanced Energy Efficiency, the Bureau of Energy has having a process called Perform, Achieve, Trade. This is called PAT. You can see it in the slide. I have given PAT cycle 1, PAT cycle 2. So what this PAT cycle refers is Perform, Achieve, Trade. Each of the industries, major industries, have been given a target to achieve energy efficiency. That energy efficiency, what they have achieved, is tradable. Suppose if they have been set a target to achieve say 5% reduction in their existing energy consumption by 5%, if they achieve more than 5%, whatever additional energy efficiency they have achieved is tradable with industries who are not able to achieve the target what the government has set. So this is something like your share market trading, industry X, which have achieved higher level of energy efficiency, can trade their efficiency certificates with industry which have not achieved their targets. So this is a market mechanism which the government of India had introduced for the 8 sectors. Initially, they have introduced the 8 sectors, namely aluminium, chloralkali, textile, pulp and paper, iron and steel, fertilizers, cement and thermal power plant. The first cycle, 478 industries were there, and subsequently the second cycle it was increased. More industries came to were added, and the number of industries was increased to 591 industries. See, this each cycle is a period is of 3 years duration. The 3-year duration, the government will set a target, and the industry should implement and achieve the target, and again auditors will go and evaluate the efficiency whatever they have achieved, and they are monitored, and the efficiency that are achieved are then converted into equivalent certificates. So in the first patch cycle, around 8.67 million tons of oil equivalent has been achieved. That is equivalent to the achieved target was more than what was the target that was set. The target that was set for the industries was 6.68 million ton of oil equivalent should be reduced. Of a million ton of oil equivalent of fossil fuel have to be reduced. But the industries have performed more than that, around close to around 8.67, 30% more than that they have achieved. So based on the success of the first patch cycle, the government has also introduced additional sectors like refineries, petroleum refineries, railways, electrical distribution companies also have they have introduced in the patch cycle 2. The results of patch cycle 2 are yet to come because of this pandemic. Many things got disturbed, and like how we are able to project that the industries have achieved savings of close to 30% in the patch cycle 1. We have not yet able to quantify the patch cycle in the patch cycle 2. In patch cycle 3, other more sectors of industries have been also introduced, like commercial buildings and petrochemical sectors have also been introduced in the subsequent cycles. So this is another market-based mechanism which the government of India has introduced, which is also contributing to for the improvement of the efficiency in industries, which finally results in reduction of the emission from power plant or burning of the fossil fuels. Coming to energy, this is on the macro level. Whatever I have talked about the climate change and how climate change impacts globally, and how the emissions can be reduced to bend the curve of achieving the 40 gigaton of emissions by 2030. So this is on the macro level. Coming to the energy management and audit in the industry level, what industries can do to do energy to control or manage their energy, so that they can also reduce the energy consumption, which results in not only in cost saving but also at the same time result in a reduced emission level, which also helps in globally in reducing the global warming by way of reduced greenhouse gas emissions. So if you look at what is energy management, broadly the definition is it is nothing but a strategy. The strategy is for optimizing the energy or minimizing the energy cost, so that you have a minimum environmental impact you are making. So even if whatever be the industry is even a very clean industry, in the sense industry as such doesn't give out any emissions. The electricity that it uses is produced by burning fossil fuels, which in turn gives out emission. So by energy management, by applying energy management and reducing the energy consumption, it not only benefits the industry by way of reduced energy cost, what it pays to the utility, it also reduces the environmental impact by reduced emission levels because of burning reduced fossil fuels. So this, when we say energy management is a strategy, what is energy audit? Energy audit is nothing but a tool to affect this energy management. So energy auditing. Yeah, I will start from this is the one I was talking about, and then what is energy management. You can go to the next slide. Yeah, so if you say energy management as a strategy, energy auditing is nothing but a tool how to achieve this energy management. So this is an effective tool in defining and pursuing energy management. Next slide, please. So if you look at the need for energy audit, you know that the three major expenses in industry has got our energy, labor, and material. So the audit gives a positive orientation to the energy cost reduction, and it keeps focus on variation on the energy cost, and it identifies technologies and retrofits that can be deployed to achieve the energy conservation. Yeah, next slide, please. So this slide gives you the typical breakup cost of wages, power and fuel in the raw material in the industry. See the dark blue one signifies the power and fuel. The light blue is salaries and wages, and the orange one is mainly the raw material cost. So for each industry, the power and fuel cost varies. Maybe if you take cement sector, it is the highest. The power and fuel cost is the highest. Maybe followed by steel sector. But nevertheless, there is a potential to reduce the power and fuel cost in sectorially, so which improves the profit and the bottom line of the industries. Yeah, next slide, please. Yeah. So if you look at what are all the key factors that are involved in the success of management? I have lost. I'm not able to see the. Yeah. So if you look at what are the key factors that are involved in the success of energy management, is the involvement of top management is very essential. The top management should set goal, like what should be its energy policy of the industry, so that based on the energy policy of the industry, the down the line it can be aligned to achieve the energy saving. And the responsibility of energy use lies with the end user. So the end user should be made accountable for what energy is being spent on the shop floor. Next slide, please. So how do we achieve this one? This is by way of having energy accounting centers at each wherever energy is consumed. Maybe if you take a engineering shop floor, you have assembly section, you have grinding section, you have utility section. So each of the sections should be considered as a separate cost center, and the energy that is consumed should be monitored, measured, so that every day it can be compared with whether the energy that is consumed today is more or less than the previous day, and if it is more, we can pinpoint why it has consumed more energy. By establishing energy accounting center for each of the cost center, it is very easy to pinpoint why there is a increase in energy use in any section on a comparative day-by-day basis. Is it because the energy consumption has increased because of the increase in production, or whatever it is? So establishment of an energy accounting center is very much essential for the success of energy management. Next slide, please. So if you look at the types of energy audit that are there, see the types depend upon the type of energy audit depend upon the function and the type of industry. Some may be a process industry, some may be a commercial building, some may be engineering industry. Based on the type of the industrial sector, the audit have to be audit strategy also have to be planned, so that we can have a very in-depth analysis. We can go to in-depth level at the audit level, so that the energy consumption can be achieved at a larger magnitude value, so that maximum amount of energy consumption can be reduced. Next slide, please. So if you look at the classification of energy audit, there are two classifications of the energy audit. One is a preliminary audit. Preliminary audit is nothing but a walkthrough audit. You try to monitor the energy consumption at the macro level. What is the energy consumption at the section wise, what is the production level, and what are all the possible low hanging fruits that can be tapped to achieve the energy saving. It is more a broad and a macro level one. A detailed audit is next is a detailed audit, which again, as I was telling, it varies from industry to industry, and it makes use of a lot of portable energy audit instrumentation that are used. It covers all the major energy consuming section. Energy balance of a process have to be developed, and so that the operating point at which the process is operated is established to find out what is the efficiency of the process. And we also have to list out what are all the possible ways of improving the efficiency, what is the investment that will be required, and what is the return on investment that is possible by way of implementing such recommendations which the auditors suggest. Next slide, please. So coming to the energy audit methodology, let's see, now we have seen the energy audit as a tool. There are two classifications of energy audit, like a preliminary audit and a detailed audit. And what is a preliminary audit, which is on a macro level, we try to tap the low hanging fruits. Under the detailed audit, we go in depth based on the sector wise. Now let's see the energy audit methodology. Next slide, please. So a preliminary audit, as I was telling, that is even an experienced plant personnel can do it. Even an external consultant can be involved for 2 to 3 days. It can be done. Basically, it involves a collection of data, the data which the plant has got in terms of what is energy consumption, be it electricity or be it fuel or coal or whatever it is, and what is the production. So a comparative analysis is done in the preliminary energy audit, and some, as I was telling, the low-hanging fruits are identified for implementing energy conservation measures, and the saving potential and investment one are estimated. Next one, please. Coming to detailed audit, it is, as I was telling, it involves the use of several portable instruments. It normally detailed audit is done by a team of auditors. The team generally consists of electrical engineers, mechanical engineers, chemical engineers, based on the type of industry it is. If it is a process industry, the chemical engineers and mechanical engineers. Of course, all audit requires a combination of all these one, but since the potential exists more for a chemical engineers, the team strength will be more of chemical engineers if it is a process industry. So generally, audit is done by it's a multidisciplinary activity which uses a lot of instruments, portable instruments which are used, and it will extend from depending upon the size of the industry. It may even go up to 5-6 weeks if it's going to be a very large audit, large size industry. The audit time frame will also go for several days. So if you look at the detailed or energy audit, it is broken into several steps. The first step is it involves basically data collection, which we do it in a preliminary audit also. But here section wise data collection is done. Like for each process and each section, the data are collected. The technical specification of the equipments are collected from the manuals. The operating, more of interaction is done with the operators at the floor level, shop floor level, and the operators to identify how the equipments are operated, what are the schedules of operating the equipment, and what level of technology are being employed or currently being used in the plant for that particular section or particular equipment. In the step 2, more of data monitoring is done through instrumentation, what the auditors carry with them. These are instruments, with portable instruments, are basically non-invasive type, in the sense you need not require to stop the process in the plant. The portable instruments can be connected even when the process is going on. These equipments can be used to collect various data like electrical parameters or flow parameters, be it water flow or oil flow, or or air, or if it is in mechanical equipment like compressors, the airflow or the temperatures which are required for the process required, which the process calls for, are all measured using the during the step 2 of the detailed energy audit. Next slide, please. Third step is analysis and finding. So once the data is collected, we have got two sets of data. One is the measured data, what we have gathered through instrumentation, and the next one is the historical data, what the plant has or having or they are monitoring in their logbooks. With the two sets of data, detailed analysis is done to find out what is the efficiency. It involves generating energy and mass balance of the process, calculating of the energy efficiency through basic engineering formulas. And once the efficiency or performance have been or estimated, then this estimated values are compared with the design value of the equipment. This is something similar to like say the car manufacturer says my car will give you 20 kilometers per hour, but on road it may be giving say 15 kilometers per hour. So similarly, the equipment manufacturer will have a performance design performance value, and we, based on the energy auditors, when they do a energy audit with the data analysis, they will come out with what is the performance of the particular equipment or the process. This estimated values are compared with the design value, and we'll try to bridge the gap. Why this gap is there? What has to be done to improve from the estimated value what we have achieved to the design value, which is the best value. So this is done in the step 3 of the detailed energy audit. Next slide, please. In step 4, some of the trials that are possible during the course of the audit are carried out to see whether the improvement in the performance can be achieved. See, even in a car, like tuning is done to improve to give a better mileage. Similarly, even in an industry, it could be a boiler or it could be a compressed air system. Whether a good housekeeping or maintenance practice can be or implemented in step 4 of the audit activity to see whether any improvement in the performance is achieved, which will result in reduced energy consumption. In some cases it may be possible, in some cases it may not be possible. In some of the cases where it is not possible in step 4, without fine tuning is not possible, it may ask for implementation of retrofits for achieving the performance of the equipment. So this is achieved by depending upon the analysis what we have carried out based on the type of retrofit that is that particular system or the process system requires. A retrofit like a variable speed drive or a change of existing pump to an energy efficient pump, or replacement of existing motor to an energy efficient motor. Such evaluations are done in the step 5 of the energy audit. Next slide, please. Coming to the step 6, the last stage of the detailed energy audit, the energy efficiency that is possible by way of performance improvement is compared with the investment that is required, and the rate of return of the investment is calculated. The possible vendors who are suppliers of the retrofits or the new energy efficient technologies are listed out in the step 6, and what is the incremental energy efficiency that is possible with the recommendation is also evaluated in the step 6 of the detailed energy audit. Next slide, please. Yeah, so these are the various steps that are involved in a detailed energy audit. So step 1 to step 6 will give you a complete picture of how to do a detailed energy audit in a plant and to achieve energy efficiency, thereby reducing energy consumption, and what are all the investment, what are the technologies that have to be deployed for achieving this energy efficiency, and what is the who are all the vendors who supply the equipments, and what is the cost benefit the company will gain by way of improving the energy efficiency, what is the financial implication in terms of investment and return on investment are calculated up to step 6. But to achieve this, you require several energy audit instrument. So energy audit instruments is a must to do an energy audit. So unless you don't measure, we will not be able to manage the energy. Now, not only several companies have understood this concept, and not only when they do energy audit once in 3 years with by using external energy auditors to achieve the performance, to improve the performance level. They also, the industries are also, or the companies are also investing on instruments so that to sustain that energy saving that is possible. See, today an auditor will come, do an audit, and give some recommendation to implement to reduce the energy consumption. But to sustain that energy consumption, the company have to continuously monitor their equipment to see their see that the savings that have been achieved by investing certain amount are not missed out, or the energy that are achieved is sustainable year on year after the energy auditing has been done. Next slide, please. So there are several type of energy audit instruments that are available. One is mainly for measuring the energy consumption alone. Some are efficiency related, which directly gives the efficiency related data of the equipment, and some are for operational and control data, to monitor the operation and control data, which will help in calculating the efficiency. So these are the different energy audit broad classification of the energy audit instruments that one need to have. Next slide, please. So these energy audit instruments are mainly used to measure the thermal parameters, mechanical parameters, chemical, electrical, and the lighting parameters. So even the not only the auditors have to use the energy audit instrument, even the companies also need to invest certain amount of money on the audit instrument to ensure that the energy efficiency which have been achieved after the post audit are sustained year on year, so that the economic benefits that are achieved by way of audit is continued. Next slide, please. So if you look at the various areas that are looked into it, I will broadly various areas that are looked into it where energy efficiency opportunities that are available are starting from the electrical system. This involves electricity supply which the companies get from the utility company. It starts from the transformer, how the transformers are loaded, the power factor, the demand management, the voltage levels. These are all the broad areas that are studied to see how the performance of the transformers. Next slide, please. Next is the electric motors. If you look at the electrical energy that is consumed, the electrical motors consumes around 70% of the electrical energy that is used in the industry. So motors, as I was telling, that motors being the largest energy consumer, now there are several upgrades of motors that are available. Several energy efficiency motors are available. The motors should be properly loaded so that it gives the maximum efficiency. So based on the loading of the motors, motors could be reshuffled wherever underloaded motor can be reshuffled with the motors of appropriate size motors. The most important one is the use of energy efficient motors. Now we have got IE3 and IE4 motors, which are more energy efficient compared to the standard motor by 5 to 6%. And there are several financial models that are available to switch over from a standard motor to energy efficient motors, which gives you higher energy efficiency, around close to 5 to 6% of energy efficiency can be improved. And reactive power compensation on large motors is also possible, which also gives a good amount of power factor improvement and thereby bringing an energy saving. Next slide, please. Compressed air system is also another one of the major energy guzzlers in a system. A good amount of energy saving opportunities is possible in a compressed air system by studying the performance and comparing it with the design specification. And invariably all industries will have leakage that is available, which is inevitable. Certain amount of leakages are permissible, and we can always carry out a leak test to quantify what is leakage that is possible, how to plug the leakage and save the energy that is possible in the compressed gas system. Next one, please. Boilers, again, boilers, as I was telling that there are opportunities that are available, be it a coal-fired boiler or a oil-fired boiler, whether first the air-to-fuel ratios are appropriate as per the design system, the steam that is generated from the boiler, when it is taken to a through different network, pressure drop causes resulting in a wastage of energy. Similarly, on the insulation aspect also, no good amount of opportunity exists in insulation by providing appropriate insulation on the steam pipelines. Also, energy can be saved. And of course, there is an opportunity to save on the condensate recovery in the process industry, where directly the steam that is generated is not used in the process. It is used in an indirect manner, and the condensed steam also can be recovered, thereby providing opportunity to save energy. Next slide. Fans and blowers, the industrial fans and blowers also. I will include fans, blowers, and pumps, or what classification of devices. And there are a good amount of opportunity we have observed in the flow control strategies, because most of the time what happens is there exists a mismatch on what is required and what is designed at the design stage to and the implementation, or there's always a mismatch between the requirement and the design, and this offers a good opportunity to save energy in the fans and blowers by different methodologies like flow control method, or by going for a higher efficiency upgrades of fans and blowers. Next slide, please. Yeah, pumping and fans and blowers are almost the same. Whatever I had mentioned in fans and pumps are applicable for pumping system also. Next slide, please. AC system also, centralized AC system also offers a good amount of energy saving opportunity in various subcomponents like cooling towers, condenser pumps, fans, air handling units, and of course on the insulation, chilled water insulation line, and the pressure drops on the chilled water that is being carried out into the various network for providing cooling. Because some of them are, it becomes even a maintenance issue also, will cause inefficiency, causing increased energy consumption. In a production plant, they try to address the maintenance issue to provide the utility what is required by the production department. They don't look into the maintenance activity whether it is performing as per the design specification. So even the maintenance system, if you look into the maintenance aspect, also a good amount of opportunity to save energy is possible. Next slide, please. Lighting system, again, lighting, now we have got many industries have switched over to LED lights, which are more energy efficient. Now many controls systems are possible based on the type of industry, like photo sensor based, dawn to dusk light sensors for street lighting. Similar kind of control mechanism are available, which also saves energy. And there are several technologies, not only LED, we think LED we have reached the highest technology in saving energy, but there are new technologies which are likely to come in another 1 or 2 years, like ceramic based lighting, which are more energy efficient than LED based lighting. So these are some of the technologies which are coming in the lighting sector also, which provides a good amount of energy efficiency opportunities. Next one. So as I was telling, in the deliverables, at the end of the energy auditing, in the different areas, what we have seen from starting from electrical system to lighting system, auditor carries out a detailed energy audit, comes out with various recommendations what can be done to reduce energy consumption. They are grouped into several categories. Some of them may be low-hanging fruit, some of them may be involving investment to achieve this energy saving. The various technical specification, the auditor has to give the technical specification of the retrofit, what he is recommending to achieve energy saving. The investment cost and the vendors have to be provided in the by the auditors. The economic viability also, like the return on investment, because most companies
they have their own return on investment. Some companies will have a return on investment of 1 year or 2 year based on their company policy. Based on that, the auditor has to categorize the investment so that the proposals which are having a low ROI will be taken up immediately by the companies for implementation, so that the benefits of energy efficiency can be achieved. Next one, please. So a robust implementation plan should be there. So if an energy auditor gives say 20 proposals or he has submitted to the management of an industry to implement, some of them will be low hanging fruit, some of them will have a higher investment one. So the management will have a plan so that the low hanging fruits are achieved immediately, so that the subsequent higher ones have to be budgeted and taken up in the subsequent period of time. In the meantime, the technical specifications, the vendor list, and other things have to be collected from the market and compared, and then a plan have to be made before starting to implement the proposals or recommendations given by the auditors. Next one, please. So energy monitoring plan also should be there. See what is the current level of energy consumption a particular section is having, and something we are going to implement it. The auditors have recommended, say, by implementing this, a 10% energy reduction is possible. So suppose if there are no metering facilities are available, the meters should be implemented before the proposal is implemented, so that there's a reflection in energy consumption is monitored as suggested by the auditors. So energy monitoring plan also should be there before starting up of the energy auditing. Next slide, please. Can I have the next one, please? Yeah, process and practices for energy conservation. We have to, the management should choose the appropriate technology. So, the auditor, being a vendor neutral, will suggest all the possible opportunities that are available. It is a management's prerogative, and management should sit and choose the appropriate technology with the guidance from the auditors. Some of them, like simple housekeeping measures, maybe, as I was telling, controls for lighting control. Even manually also lights can be switched on and off, or even have an expensive control. What can be done and what can be done manually, or what can be done using a technology intervention. Those things have to be on the prerogatives of the management. Management. So all those things have to be listed out before the energy conservation plan is implemented. Next one, please. Coming next is the financial part of the implementation part. If the company or the management is having a budget to implement the energy conservation proposal suggested by the industries, by the auditors, they can go again, they can go implement based on whatever the budget that is available with them for implementing the recommendation. Otherwise, what the industries or what is the trend that is going on in the market is to engage the service of ESCO. ESCO is nothing but energy service company. The ESCO, what it does is they bring in the finance to implement the energy conservation measures that are suggested by the industries. The entire costs that are involved in implementing the proposals are borne by the ESCOs. I will show you the next slide in the what is the structure of the ESCO. Next slide, please. Yeah, so ESCO, as I was telling, is the energy service company. So once the audit report is prepared by the auditors, yeah, sort of understanding or MOU is signed between the ESCO company and the ESCO and the host company. The entire drawings and the project design specifications have to be in the initial stage itself. The ESCO has to furnish to the industry, and what are all the possible savings measures that are possible have to be put in the investment grade report itself. Next slide, please. So in the audit report, the investment grade report, a baseline has to be established. A baseline is nothing but what is the current energy consumption level for the current production level. So now something is going to be recommended to implement. So by implementing this, how much is the energy consumption going to come down? So this will result in a positive cash flow or positive cost savings that is going to be achieved. So now the ESCO is going to implement the project, and there are going to be guarantees that has been signed between the ESCO company and the management of the company, how they will share the benefit that is going to accrue. Can I have the next slide, please? So this is one structure of a shared saving model between the company ESCO and the company and the ESCO. So here host is a company where energy service agreement, energy services, it has taken the service of ESCO. So in this shared service model, the ESCO brings in the finance. It either invests its own money or takes or borrows money from the bank, and based on the money it borrows from the bank, it invests on the energy service energy recommendation that it has submitted to the company. So an agreement is signed between the host company and the ESCO company. So here what happens is suppose the ESCO tells the host company, say 10% saving is possible in your plant, and we bring in the investment for achieving this 10% of the energy saving. So suppose in this process, say 1 lakh rupees is the saving that is possible in this entire energy saving that is possible. The maximum amount of savings will be retained by the ESCO, because ESCO is only the company which brings in the investment, and little amount of money is be shared with the host company. This agreement will continue till the ESCO recovers the investment, whatever it has made on the investment, and once it recovers the investment, what it has made on the investment, then the assets and other things are transferred to the host company. In this case, the host company, it lends its facility to the ESCO company. The ESCO company brings in the investment, puts in the whatever equipment that are required to achieve the energy saving, and it retains the maximum amount of savings that has been achieved through the implementation of the recommendation of the various proposal, and shares a certain amount of savings with the host company for a certain agreed period of time till the ESCO company recovers the investment, and then the assets are transferred to the host company. Next slide, please. Next is a guaranteed saving model. In this model, the host company will themselves will agree to put the investment, and they will only ask the ESCO to stand guarantee for the energy saving, because it is only the ESCO company which has done the energy audit and then come out with the investment grade report saying that 10% saving is possible. So in this guaranteed saving model, the host company will say, no, you don't bring the investment. I myself will have the bring in the investment. You only stand guarantee for whatever percentage of energy saving you are proposing in your audit reports. So in this case, the risk is lies with the ESCO company only. So suppose here the 10% energy saving the ESCO claims. If there is a shortage of energy saving that is achieved, the ESCO has to compensate the company. The gap has to be compensated by the ESCO company to the host company. But otherwise, if the savings are achieved, the ESCO companies will get its share of the saving, whatever it has been projected in the agreement what it has made with the host company. So these are the two basic models which are emerging in the market for implementing the energy saving. I was telling in an industry, maybe motors or pumps, or these are the major equipments which are there, which are the major guzzlers of energy. So there are several financial models that are being implemented by this way to implement energy saving. through the ESCO model in industries. Yeah. Coming to the next slide. So this is the cash flow model. So how the ESCO companies and the host companies are getting benefited. So now we have a old energy bill. By implementing the different energy conservation measures, the energy bill gets reduced as shown in the graph, and whatever that is savings that are achieved, it is shared between the ESCO company and the host company. Based on whether it is a guaranteed saving model or a shared saving model, the percentage of sharing varies, and both of them are getting benefited in this model. So this is the basically the cash flow model in this kind of performance contracting methodologies that are implemented in the implementing the energy savings model. These are a type of business model. If industry is having the money to implement, it will implement on its own. If they don't have the cash, they bring in a third-party ESCO company to implement it. Even if the company is having cash, and if they feel there is a risk in investment or investing on the technologies, the companies who have done the auditors, they stand guarantee for achieving the energy saving in the industries. So these are the different business models that are evolving in the industries in implementing the energy efficiency proposals that are developed by the energy auditors. Next slide, please. So if you look at the benefits of ESCO, it's simple that the customer, he need not commit his money because most of the industries also have to borrow money from banks to implement several projects. So in this case, the money is brought by the ESCO companies, and they stand guarantee also for the whatever they are proposing, and it is all backed up by several legal documents so that the investments are safe. So even if the company is going to borrow money for implementing a project, there is no guarantee that the savings are going to be achieved or not. But whereas if the company gets into a contract with the ESCO company, it is backed by a legal document where the guarantees are assured, so that the probability of failures are minimal, and even if there is a failure, the savings are not met, the ESCO companies are bound to compensate them the gap what they are not able to achieve by way of implementing the proposal. Next slide, please. So it's a win-win situation. The customer company benefits, the ESCO company benefits, the vendors, everybody benefits, because each one is looking into their area of domain only, and so this results in a division of expertise, and each one concentrates on their area of expertise, so that finally both can achieve their best. Because otherwise the company, they are good in the production activity, they may not be good in implementing an energy management plan. So things can go wrong. Whereas if you outsource it to ESCO company, of course there is a service fee have to be paid to the ESCO company. They will do a good job, and it is backed by legal documents for achieving the guarantees what they promise. Yes. Next slide, please. So these are all the traditional way of which the energy auditing was going on. But the latest development in the technical side on the energy management that is evolving is IoT based energy management. IoT is nothing but Internet of Things. So this is a computerized cloud-based energy auditing technology which are been evolving in the market. Though it is very new to India, these are the kinds of things that is practiced in advanced countries and developed countries. So the problem is here, one is there are not sufficient meter data are not available. There are unavailability of real-time data. So that is why the auditors go with their own portable instruments to measure what is actual data that are available, to collect the data for analysis. Expensive and complicated EMS systems are required, and because of the losses and penalties because of non-availability of alerts for critical situations. These are some of the problems in the industry. Next slide, please. Next one, please. Next one. So these are all addressed by a way of latest IT based model, where you have the production line machine component at the lowermost layer. On top of that one, you have the monitoring gadgets like sensors, energy meters, and other IT based solutions. And these data which the energy meters and sensors generate by collecting from the different machines or production lines are passed through a gateway to a local server. The local server will have the softwares that are used for analysis of the data, what it captures through these sensors. And then these data are then passed for implementation or.
Just 1 minute, sir.
Yeah. And these data, whatever that have been collected into the local server through the gateway, are then analyzed using a software-based solution to automate certain process, like through SCADA or through web application. So this has come. This kind of models or this kind of technology evolution have happened in the energy auditing field. Currently, what is being practiced in India is, if you can say, is a very where the auditors go to the site with the instrument, collect the data, use their own laptops using engineering formula to recommend what is the current level of efficiency level, and then suggest them what should be done to improve the efficiency by way of retrofits, or by way of, or even if some companies they may have advanced technology, but dynamically it has to be varied to achieve energy saving. These are all done by way of physical presence of auditors, calculating it at site and then suggesting them to do what has to be done to achieve energy saving. But now we are moving towards an IT based methodology where data are, you need to install the sensors and energy meters, collect the data, data are analyzed in the server level, and then the analyzed data are then sent to automatic equipments. Either it could be there, or those automatic devices have to be installed, and then these devices in turn will control the equipment to operate them in a more energy efficient manner, thereby reducing the energy efficiency, or thereby reducing the energy cost. Next slide, please. So this is a business value with real-time monitoring. So start with, you have device connectivity and device forwarding. Then real-time it is monitored. Then the data analytic is done. Then automation is the analyzed data is used to automate the process, and then in turn it goes to the board level. No, it gives alerts to the owners of the equipment or the process, or even to the top management level. Know what has been done and what has been achieved. So this is the kind of next phase, I can say, in energy auditing field, which will evolve, or which is evolving, the process of evolving to have a higher level of confidence and higher level of possible energy saving that is possible with these kind of methods. Next slide, please. So I will share some of the case studies where we have done energy audits both in India as well as in outside the country. So these are some of the petroleum sector where we have done energy audit, where we have achieved a saving level of around close to 2 to 6% based on the process level of process. Some of the processes are advanced level process where savings are less, or some of the processes are maybe not that level of advanced process technologies are implemented where saving opportunities are high. Next slide, please. This is on water supply systems, where we have done in not only in India, several countries where these countries which are on the same level of developmental stage as like our country, where the saving potential or as high as 25% is also possible in some of the systems. This is basically in water supply and electrical supply systems. where the potential savings are 3 to 25%, and these are in hotels or basically commercial buildings like shopping malls, hotels, public buildings, hospitals, universities, where the saving potential we have achieved up to a range of 5 to 30% have been we have seen and achieved. Next one, please. And this is on again coming to airports, where we have done on energy audits on some of the very sophisticated airports like Delhi Airport, Mumbai, Hyderabad, and in other countries or like Maldives and other places where we have achieved a saving percentage of between 5 to 15% of energy saving we have achieved. These are again in fast-moving FMCG industries like breweries, food industries, paper industries. Saving percentage of up to 18% we have able to achieve. Coming to the next is the renewable sector. This is one is the energy efficiency. Next is the renewable energy, which is again getting popularized. We know mainly the fossil fuel is also obtained through sunlight. So where solar energy is used, solar energy is converted to fossil, and that is converted to electricity and light. Next one, please. So now currently solar energy is extensively used in water heating, solar panels in industries. They are integrating this renewable energy in industries in a large way. Next slide, please. So we are seeing in many industries, now they are going in for rooftop installation of solar panels, thereby integrating the solar energy that is generated and directly used in industries. Each state has got different regulatory model, and based on the regulatory model, is the integration of renewable energy is being carried out by industries. Next one, please. Again, coming to solar thermal, this is the previous one is on solar electricity. Solar thermal, where steam and hot waters are used. This kind of parabolic reflectors systems are used for generating hot water systems, or even for thermic fluid heaters, which require higher temperature like 200 to 250 degrees Celsius, are also easily met using this kind of solar concentrators, which are also the industries are adopting in India. Next one, please. Again, wind energy. Wind energy, we all know that wind is generated at specific location in the country where the high wind velocity is available. Next one, please. Now the latest model is wind energy is available for around close to 6 months in a year, and generally during the monsoon period. Whereas solar energy is available throughout the year, but during daytime only. Now a combination hybrid of wind and solar is getting popular in power sector, where during the daytime solar energy is generated, and even during the night time during monsoon period, good amount of wind energy is generated. So such hybrid wind farms are being developed in India. But of course, these are the power sector only, not at the industry level. Next slide, please. Offshore wind farms are also getting popular. Again, these are in the power sector. A single windmill itself can cater up to close to 10 megawatt of wind energy generation. Next one, please. Then biomass is also one of the latest source of energy, which is extensively used in industries like sugar industry, where the bagasse that is generated, or agricultural based industry, the agricultural residues that are used in boilers to generate steam and electricity. Many industrial sewage and municipal solid waste are also directly can be used in a biomass generator to generate thermal energy as well as electrical energy. Next one, please. This is the future scenario is the integration of both renewable and electrical energy with automation. This is where we will be moving towards. The industry will be moving towards. So the industry will be procuring energy not only from the distribution company. It has got the freedom to choose energy, whichever energy it can procure, be it biomass or solar or wind, based on the cost of the energy that is available at different points of time. So this will evolve, because during monsoon time excess wind will be available, which can result in high amount of wind energy generation, resulting in a reduction in the cost of wind energy. So the industry can have the option to choose energy. So eventually we'll be moving towards this kind of smart grid application with integration of renewable energy, so that the industries will be highly benefited to manage their energy. Next slide, please. I'll just touch upon open access with 2-3 slides. Open access, next slide, please. So traditionally, we have industry where the generating company is there, a transmitting company is there, and it supplies energy to the end user. It could be either industry, commercial, or the residential consumer. Next slide, please. Open access is it is like today we have got our mobile phones. You can have either the Jio or Airtel or Vodafone, whomever be the service provider, you can choose. Similarly, open access system is the one where large consumer of more than 1 megawatt of power they are going to consume, they have got the freedom to choose from whichever service provider they wanted to choose. So what happens is a market mechanism is brought into the picture, so that if somebody at some point of time they are able to supply power at a lower cost, the consumer has got the freedom to choose from that particular distribution company. Thereby he can reduce his energy cost that is he is incurring. Next slide, please. So earlier it was very restricted. Now the regulation has come into picture, so that it is like the regulation have been loosened, so that the industries have got the freedom to choose from whichever generating company has got excess power at that point of time. By this the distribution company is also benefited, because if suppose if the energy cost is say 5 rupees at particular distribution utility is selling, and at some point some northeastern place where hydro potential is very high, because of monsoon they are generating at a cost of generation is only 2 rupees per unit. A company which is situated in the eastern sector can get the power from the northeastern place where it is excess generation is there. The existing distribution company also gets benefited by way of transmitting the power. They also charge a minimal amount for transmitting the power, and they also get benefited. The end user, end consumer, or the end company who buys this power at a lower cost is also benefited. So this is again a win-win situation between the generating company, the transmission company, and the end user. Yeah. So these are all some of the what was prior to the power trading situation, and what has changed after the introduction of the power trading by way of regulatory mechanism. Just can you go to the next slide, please? I will. I will explain this with this the emerging structure. If you look at the lowest one, we have got the different consumers like domestic, industrial, commercial, everything. Above them is distribution companies. Traditionally, we were buying them only from, there is a monopoly. Like how BSNL was there, only we were tied up with BSNL. After the telecom regulatory came, and our mobile, we can choose whomever be the our mobile service provider. Now the transmission lines are there, but we can buy power from whomever generating companies it. But the power flows through the existing transmission line only. So large consumers have been given the freedom to choose or buy power from whichever generating companies who are offering at a different price at different time. So it is becoming like a model where you sit in front of the computer, some XYZ company is selling power at a very low price, and I can bid for that one and buy that power. If the present company from where it is buying it is higher, then they can buy from a source who provides at a lower cost. So this is a market mechanism which helps companies to manage their energy cost in a very profitable manner. Next slide, please. So the advantages of power exchanges, the companies are directly benefited by procuring low power otherwise which goes waste, because otherwise nobody is will be using that. There is no end user to take that power which is lower cost. But because of this open access system which has come into picture, anybody can buy power who supplies at the very lower cost, and by this everybody is benefited this way. Next slide, please. So to conclude, what I will say is there is a potential of around 300 gigawatt of new power saving is possible by 2040 by way of energy efficiency itself. This is a projection by the government of India. If all industries implement energy efficiency and save whatever possible that is in their industry, an avoidable 300 new gigawatt of new power generation can be avoided by up to 2040. And as I was telling in my first initial slide itself, the renewable energy market, we will be reaching the target is 175 gigawatt of power by 2022, which is easily we will be achieving it. And then the government has hiked the target to 450 gigawatt by 2030, and which looks very optimistic. So, but what is that we are going to achieve by reducing the energy efficiency and integrating large amount of renewable in our existing power sector? The companies are benefited in terms of reduced energy cost, and globally the emissions are going to be reduced because of lesser burning of fossil fuels, because by switching over to energy efficiency and renewable energy, thereby we are going to avoid the climate change, which is threatening us, which is threatening and in front of us. Next slide, please. Thank you. I think with this I will conclude my speech. I think I have taken more time than what I had planned. Now the floor is open for Q&A. Anybody is having a question, I can try to answer to my best of my level.
So the session is now open for question and answers. If anybody has any question for Senthil sir, please go ahead.
Good evening, sir. This is Chandan Garai. Sir, I have one question regarding electrical energy savings. And are we considering the losses in the plants? Whether like saving is one other part, what are we considering the how to minimize the losses, like transformers or some other equipments? How do we capturing on the data?
Yes, exactly. We are trying to reduce the loss, thereby improving the efficiency. If you look at transformers, operating efficiency of the transformers are evaluated or calculated, and the loading on the transformers are rationalized. Power factor improvement, by improving the power factor, you can reduce load losses on the transformers. So these are some of the areas that are looked into on the transformers side. Thereby, the losses are minimized and to improve the efficiency is improved.
Yeah, sir. One thing I just want to indicate that in a low voltage side, we normally use in most of the cases we are using dry type transformer up to 2500 kV. Okay. There we in the standard also there is no defined losses. Like it is not mentioned that you have to consider this much of losses only. It is that, but in higher side we do loss calculations. So why is it so? Are we not considering the low voltage side losses?
No, we have to consider the LV side losses also. See, it is up to the.
But the low voltage side, loss capitalization formula is not being used. In the high voltage side, it is being used.
No. By metering we can do no. By metering, we can calculate what is the losses and whether the losses are on par with the design values of the transformer as per the original manufacturer.
Okay.
See what happens over a period of time because of core saturation and other thing, the losses will increase. So you have meters. That is why I was stressing the importance of metering. Have meters, monitor the losses, and you compare it with the design values of the as given by the original equipment manufacturer.
Yeah. So one implication is that in the downside, in this low voltage side, the losses are not the maximum losses are not defined. So if you see in the low voltage side, lot of manufacturers throughout India. But if you see in the high voltage side where we do loss calculation, the players are very limited. So do you think that the loss capitalization or the maximum losses in the low voltage transformer shall be limited?
Sir, actually, low voltage losses are also defined in most of the standard companies. Like if you look into either Crompton Reeves or Kirloskar or major transformer manufacturer give what are the no load losses and load losses of the transformers.
No, I'm not talking that companies do not define the losses. They define the losses, but whether there shall be any standard to limit the losses, like maximum loss shall be like
okay.
that.
Like you must have heard about the standards and labeling, which program, which we have got these electrical appliances star labeled, the air conditioners, fans, whatever it is. Like that, even transformers are also, this Ministry of Power is have taken up the process of labeling transformers are also. So they define what should be the losses of the what should be the best or the minimum losses a particular transformer should have.
Yes.
So it has the process has already started.
Okay. Okay, I think I do not have much on this right now. Any other person can.
Thank you.
Thank you, sir.
Yeah, good evening, Mr. Senthil once again. This is Manmohan Singh from Dusro.
Good evening, sir. Go ahead.
Indeed, it was a very informative session. A topic something very close to our hearts. I would just like to understand the obligations of DISCOM with regard to the new Energy Conservation Act.
New see the obligation is one is they have to supply electricity at the specified frequency and voltage as defined in the grid code. And next is the harmonic levels also. There is it's a two-way level. One is the industry should also not dump harmonics into the grid. And similarly, the electricity distribution company also should supply a harmonic level less than 5% for a 66 kV consumer.
So basically, it's asked for the quality power.
As for the
Quality power.
Exactly, that's what the power quality. The new electricity, the new this one, the important implication for industry or on the power quality. One is the frequency and the voltage level. It should they should comply with the grid code.
Yes.
And from the company side, from the industry side, they should not dump a harmonic level more than 10%, I think, for 33 kV level. More than 10% they should not dump. And the voltage, whatever they supply also, the harmonic level should be below 5% for a 66 kV consumer.
Thank you, sir. Thank you so much.
Thank you.
Sir, regarding this harmonic issue, when it came, I just came to my mind that see the government mandated some regulations that in the point of common coupling, we should have this kind of harmonics. Okay, but if you see the low voltage side where the actual maximum harmonic loads are connected, there is no defined standard. Like if you ask any drive standard, VVV drive standard, I need this to meet 519. They will also 519 doesn't imply on the low voltage side. So they say it's a common, so they do not comply at all. They will only give you some harmonic data at later stage when the design is done, and they will tell this is the harmonic data. Now you take care with your own. So this has landed up in a big problem to us.
Correct. See, correct. What you said is very correct. The IEEE 519 talks about at the point of common coupling.
Yes.
There is no harmonic dumping into the grid. At the low voltage side, see, it is up to the this one to the industries to take care of their power system, whether putting filters or isolation transformers or DC or chokes, AC line chokes to limit their harmonic. See, my suggestion in this one is, see, normally the harmonic level at the LV side will be high depending on the loading on the motors or driven equipment. See, most of the inverters currently, what I see in the industries are 6-pulse inverters. See, 6-pulse inverter, if you upgrade your inverter technology to say 12-pulse inverter, the harmonic generation at source itself will come down.
Yes, sir.
Then you need not look out for a solution for whether I should put active filters or whether I should go for isolation transformer. You need not look into that solution. Of course, there's a cost involved in going for a 12-pulse inverter technology, but it is a more prudent or prudish. I will say it is more wise to go for a slightly invest high in your inverter technology so that you don't end up with a problem and then look for a solution later.
But if we ask them again, if we define the 12 pulse, give me 12 pulse. So even they will say, no, I do not comply with any standard. They will say.
You see, there is no standard at the LV level because what harmonic is generated at the LV level depends upon the loading of the particular equipment.
Yeah, that's true.
Okay, at a low loading, harmonic content will be high, but the harmonic current will be less.
Yes.
So the only solution they will give you is AC line choke to ensure that your harmonics are suppressed at the source. But what a line choke does is it increases additional losses also. It will, of course, definitely it will suppress the harmonic, but it will definitely create some additional losses at the choke. So one way of avoiding that losses also is to go for a 12-pulse technology, which will effectively reduce the generation of harmonic at the source itself.
Okay. Okay, thank you, sir.
Thank you.
Any more questions for sir? Okay, I think there are no more questions, sir. So thank you, sir. Now I would like to request Mr. Amitabh Bhattacharya, Secretary JMA, to please present his thoughts and thank our guest speaker.
Am I audible?
Yes.
Yeah. Good evening, everyone. And first of all, let me thank Mr. Senthil Kumar for such an enriching session. I think it was pleasure having you on the JMA platform. I think he touched on a lot of important topics, covering from the lot of technical stuff to the financial part to the IoT-based systems, renewal. I think every part of the energy consumptions and the energy management, I think he has touched. I think all the people who are attending this session must have got a lot of information and value from the session. And thank you, Mr. Senthil Kumar. We look forward to have you again on board on the JMA. And it was a pleasure having you on the JMA's platform.
Thank you, sir. Thank you.
Thank you, Amitabh, sir. And on behalf of Jamshedpur Management Association, I would like to thank all the participants who have joined us on a Saturday evening. So for more upcoming events, please follow JMA on social media. Thank you so much. Have a great evening. Thank you, Senthil, sir. Bye.
Thank you.